Hello, welcome. And this is a presentation from Group 2. And we are presenting on adsorption separation technology. Okay, so this is the content outline for the presentation. The first part is the introduction, followed by the basic principles, the types of adsorbents, the adsorption isotherms, the adsorption process, its industrial applications, some advantages and limitations, advancements in adsorption technology, some future directions, and finally the conclusion. So the introduction, the definition of terms. We have the adsorption. The adsorption is the process by which a solid holds molecules of a gas or liquid or solid as a thin film on the surface of a solid, or more rarely a liquid. One may ask, what is the importance of adsorption separation technology? This whole thing is used for separating components from mixtures, especially in chemical engineering. Some applications are used in air and water purification, gas separation, and industrial processes. So in this picture, the raw water, as it enters into the bar, is impure, composed of suspended particles, oil emulsions, bacterial cells, colloidal haze, divalent ions, monovalent ions, macromolecules, protein, submolecular organic groups, viruses. As it passes through the transmembrane filters, it keeps on getting cleaner and cleaner until we get potable water. Basic principles. Adsorbent. This is the material that absorbs another substance. The adsorbate. This is a substance that is absorbed on the surface. Types of adsorption. We have the physical adsorption, not the physisorption. This physical adsorption is having a lower enthalpy of about 20 to 40 kilojoules per mole. Normally in physisorption, the gas is accumulated on the solid surface due to weak forces known as the van der Waals forces. In physisorption, the liquid lacks specificity because the adsorbent, that is the surface or the material on which the process of adsorption takes place, in the given surface does not show any particularity. It has a reversible nature, that is, in physisorption of a gas by a solid, this can be reversed back to a solid by a gas. Chemical adsorption. Chemical adsorption, also known as the chemisorption, is a type of adsorption which takes place in adsorbed substance that is held by chemical bonds. Chemisorption has high specificity, that is, it is highly specific and takes place if there is a chemical bonding between the adsorbent and the adsorbate. Chemisorption has an irreversible nature and it also favors high pressure. Due to chemical bonding, enthalpy of adsorption of chemisorption is high, nearly around 80 to 240 kilojoules per mole. Physisorption of a gas absorbed at a lower temperature may be converted into chemisorption at a higher temperature. So this is the picture distinguishing between the physical adsorption and the chemical adsorption. Types of adsorbents. We have the activated carbon, which is having a high surface area used in air and water purification. We have the zeolites. This consists of microporous minerals, which is effective in gas separation. We have the silica gel, which is amorphous form of silicon dioxide used in moisture control. Metal oxide frameworks, which is having high porosity used in gas storage and separation. Have you ever wondered why sometimes we buy shoes and bags and there's silica gel in it? I think you never thought of that. Well, this is used for moisture control and is a form of adsorption. Okay, so in this picture is the activated carbon, the zeolite, the silica gel, and the metal organic framework. Adsorption isotherms. We have the Langmuir isotherm, which assumes monolayer adsorption on a surface with finite adsorption sites. The Freundlich isotherm, which is the empirical model describing adsorption on heterogeneous surfaces. We have the BET isotherms or the BET isotherms, which extends Langmuir's theory to multilayer adsorption. The adsorption process. We have the pressure swing adsorption, the PSA, which utilizes changes in pressure to separate gases. We have the temperature swing adsorption, which involves changing the temperature to regenerate the adsorbent. We have the vacuum swing adsorption, which uses vacuum to dissolve absorb gases. So this is a picture of the pressure adsorption technology. Some industrial applications. In gas separation, it's used in purification of hydrogen, removal of CO2 and other gases. In water treatment, it is in removal of contaminants such as heavy metals and organic pollutants. In air purification, it's used in removal of volatile organic compounds and other pollutants. In chemical processing, it's used in separation and purification of chemicals in the manufacturing industries. So this is a picture of the water treatment. As the influent is introduced into the system, it will come out as a potable water, as the effluent. With this, all the impurities are taken out. The sludge and the micro sand, the sludge, all of them will be taken out and will serve as a form of purification process. Okay, so in this picture I have the advanced oxidation process, the flocculation, the adsorption process by materials, the membranes, and the precipitation. All these are technologies for water remediation. That is, in what the water treatment process, one may use the advanced oxidation processes, one may use the precipitation, one may use the membrane separation technology, the flocculation, and the adsorption by porous materials. Some advantages and limitations. The advantages include high efficiency and selectivity, reusable adsorbents, and is environmentally friendly. Some limitations: high initial costs, sensitivity to temperature and pressure changes, potential for adsorbent fouling. Some recent advances in adsorption separation technology. Development of new adsorbents, enhanced performance and selectivity. Integration with other technologies, that is the hybrid systems for improved efficiency. The nanotechnology, that is the nanoscale materials for superior adsorption process. And so in this picture, you have the adsorbent and the surface complexation, intracellular bioaccumulation, organic microprecipitation, ion exchange, chelation, electrostatic attraction. All these are water pollutants, the either in molecular form or the ionic form. So in the development of the adsorbents, you have the nanotechnology. This one uses nano scale materials for superior adsorption technology. In the development of the new adsorbent, you combine some things like lead, oxygen, nitrogen for the production of new adsorbent materials. And the introduction with new technologies. Okay, so let's take this case study in application of adsorption technology in water treatment. Taking this problem, contaminated water with heavy metals. Solution: use of activated carbon and zeolite for adsorption. The outcome: significant reduction in contaminants, improved water quality, and more potable water. Future directions in adsorption technology: research on new materials, developing more efficiency adsorbents will help improve the productivity of the country. Sustainable practices: focus on green chemistry and renewable resources, that's which is less hazardous as compared to the ones using more chemicals. Technological integration: combining adsorption with other separation technologies for enhanced performance. Okay, so the green technology, you have atom economy, in situ analysis, renewables, safer chemicals, catalysis, and safer solvents. So the conclusion, the whole summary of the presentation: the adsorption separation technology is a versatile and effective method for various applications such as water treatment, air treatment, moisture control, that is using silica gel, gas separations, that is example using the zeolite, and gas storage and separation, that is using the metal organic frameworks. Some future potential: continued innovation and research will drive advancement in the adsorption separation technology. Some references: Adsorption Theory, Modeling and Analysis by Ralph T. Young. Principles of Adsorption and Adsorption Processes by Douglas M. Ruthven. Adsorption Separation Technology and Design by W. James Thomas and B. Crittenden. Adsorption Processes for Water Treatment and Purification, edited by Adram Bonilla Petriciolet, Debiendu Sakal, and H. Ferken Shahid. Adsorption technology for the removal of per and polyfluoroalkyl substances in water. Recent advancements in technology of adsorbent by post-combustion, that is CO2 capture, by S. Choi, J. H. Drace, and C. W. Jones. Adsorption of phenolic compounds on activated carbon, that is in equilibrium kinetics and thermodynamics, by A. Dabrowski et al. On colloids and surfaces. End of the presentation. Thank you.